I'm excited about all the announcements that have already been made at this conference and the focus on containers and containerized applications and the first class support for Kubernetes clusters, which are just have a whole other level of complexity. What I'm excited to talk about today is something that you can use today. I mean, you could use it last year, and that is your containerized .NET applications in Azure Container Apps. And I'm going to talk about how Azure Container Apps provides some simplified support on top of a Kubernetes cluster that Azure is hosting for us so that we have a sort of a simplified control surface on top of the full power of Kubernetes. And that allows .NET development teams who want to start containerizing parts of their software system to do so and can have an easy glide path into the world of containers. And then down the road, perhaps some of the system needs all of the knobs and whistles of the full Kubernetes cluster, but it's a fantastic on ramp into the world of containerization for people who are either still deploying their software to virtual machines or even to Azure App Service. Because if you are .NET 5 and above, you can containerize your apps. And so with the .NET Conf really just a week ago, at this time, .NET 9 has been announced and released, a new version of Visual Studio and C# 13. But we're in the context of that, we're going to focus on the support that Octopus Deploy has right now for containerized applications running in the flavor of Kubernetes that is Azure Container Apps. So I'm going to dive into that today, and we'll have time for questions. So, quick summary of ClearMeasure. ClearMeasure is a full-service software architecture and engineering firm that serves companies that are building mission-critical software systems using .NET, Azure, and other Microsoft technologies, developing custom software, and rescuing failing projects. And we are also the North American consulting partner for .NET for Octopus Deploy, and we really love that partnership and helping .NET teams be absolutely successful using Octopus Deploy to deliver custom software. And a quick free offer: I just wrote another book. It literally just came out about a week and a half ago. You can find it on Amazon, The 5 Pillars: Leadership for Effective Custom Software. It's a software leadership book for architects and managers, but a free offer for this audience. If you'd like a free electronic copy of the entire book, just send me an email, get me a note somehow, and I'll get you that. And it kind of pulls out some of the methodology that we use to advise our clients to help make effective software teams. So with the relationship with Octopus Deploy, I've enjoyed giving some previous joint webinars with Paul, and we've been working with him since he founded Octopus Deploy. It's been a really great partnership. But let's get into the containers. And you've seen this slide a little bit earlier today, where Octopus Deploy is investing in Kubernetes continuous delivery, in the developer experience, in the platform engineering. And there's a lot of goodness, a lot of investment that is being made with the Argo acquisition and baking some of those features directly in Octopus Deploy and merging those ecosystems to make software engineering teams able to move fast and cycle quickly and ship software at a very rapid pace. And that is going to make it even simpler to use the full power of Kubernetes for your containerized applications. But let's kind of pull in the scope a little bit and talk about the containerization workflow right now for the current version of .NET 9. And by the way, just so if you're wondering, there's very little difference in the DevOps process between .NET 7, 8, and 9. So if you just moved from 6 to 8, if you're doing the long-term releases, don't fret about the version because you're going to be fully supported. And the direction that Microsoft is going with .NET Aspire is only going to give you a better return on investment for containerizing your .NET applications because Microsoft, with the .NET tooling, is streamlining the developer loop and deployments and integration, and all of this is going to end up making it even easier to do world-class platform engineering because the .NET platform is focused on being absolutely cloud native, with better observability and scalability, a series of libraries that are available in NuGet. And the .NET team is specifically investing more and more in containers and non-root by default and smaller base images. Just in the last year, there's been a whole lot of improvements on just the size of the containers. And so there's been a lot of really good investment in there. And so now is the perfect time. If you're not already, now is the perfect time to just modify the way that your .NET applications are being built, packaged, and deployed and operated as really the entire industry moves to containers. So hopefully the demos that I show you will kind of give you a glimpse on how you can use your existing .NET applications that are .NET 5 and above and make use of this. Now, let's give you a quick overview of the sample application that I'm going to talk about. This is one of the views of the C4 architecture method using plant UML, a diagram generated with VS Code with the plant UML add-in. But it's three components, and I'll show you the Visual Studio solution in just a minute. It has a Blazor WebAssembly front end, which is effectively it's the front end is going to run in the browser, and then there's a .NET Process, our web service or our app service that runs literally as a website with some web API controllers that our Blazor WebAssembly app calls into, and then that application is going to call to an Azure SQL database. So this is pretty much a standard architecture that everybody has. Everybody has kind of a front end, something running on the server, and then some type of database. And then of course you have a lot of other things. But everybody has this. And so that's what we're going to be looking at. Now, I do want to share with you how Azure Container Apps is structured before we even look at Octopus Deploy deploying it. You've seen a lot of Kubernetes content, and so you're probably familiar with the concept of a Kubernetes cluster. And then within that, you have the networking, the VNet and the subnets. And then inside its own networking subnets, you have pods. You have multiple pods. And each of those pods can run multiple containers. But a pod, I think of a pod as a scaled down virtual server. It's going to have a private URL that we can layer on DNS and we can access things. So I can have multiple containers inside of a pod, but of course I need to know that, and I need to make sure that only one of those containers is asking for port 80 and asking for port 443 because they're all going to share the same networking, but I have multiple pods. So in that environment, we use Azure Container Registry to publish Docker images, our container images, and we can do that through our command line tooling inside Visual Studio. So let's talk about the corollaries with Azure Container Apps. There's two big concepts inside Azure. One is the Container Apps environment. When you create a Container Apps environment, you are effectively creating a Azure Kubernetes cluster. Okay, with that single click, you're creating a Kubernetes cluster. And then inside that Container Apps environment, you create multiple Azure Container Apps. Each container app itself is a pod, okay? And within the container app, you can assign a main app container And then you can also add in different other containers to be initialization containers to run before your regular container. And you can also add sidecar containers so that you can have side jobs. And but within that container app, it is a Kubernetes pod. And so the containers you run inside the container app, they need a little bit of coordination so that you don't have any port collision, so that they're not trying to claim a port that's already claimed. And within a container apps environment, just like a Kubernetes cluster, you can map storage volumes, you can map Azure files, blob storage, and just like a virtual server, you can have your code that's running inside a container app, which is a Kubernetes pod, and you can have it reference um, a file share, just like it was a UNC share. And as long as the container app environment has that mounted over to Azure files, you can effectively have .NET code that thinks it's just accessing regular local files, and in effect it is, because you have storage that is connected to the container apps environment, your cluster, and your pods, your container apps, they have access to those volumes. So in a lot of ways, there's a lot of correlation. So it's an easy bridge to pull your .NET apps up where they might be used to reading and writing files, and you can just mount the drives effectively. So these are the parallels. That's what we're working with. So I wanted you to have that foundation. Okay. Now, from a platform engineering process perspective, this is the flow that we want to cause to take place between our build server and Octopus Deploy and Azure. And there's a lot of great tools in the ecosystem. This particular diagram shows the architecture with Azure pipelines, but the shape of this DevOps environment is exactly the same if you use GitHub Actions for your build server, or if you use TeamCity Cloud Edition from JetBrains for your build server, or any of the others. Remember, build servers build and package and run tests. Those are the big activities of a build server. Octopus Deploy deploys to environments, manages environments, executes runtimes, and helps with operation of those environments as they run your custom software. And so there is a method where you can have a build server completely hand off to Octopus Deploy, but in our first environment, we want to run full system tests. And so we like to use the flavor where we actually create a release and deploy, wait for it to finish, and then let Azure pipelines get control back so that it can run full system acceptance tests against that deployed environment. But effectively, I want to hone in on the three environments. There are three distinct types of environments in any kind of DevOps environment. You need at least one of each. The last one is production. Everybody knows you need at least one production environment. Pulling back from that is a manual test environment. Everyone needs at least one manual test environment, and most teams choose to have more than one manual test environment. You may have staging, you may have manual QA, you may have development team test. You can have as many as you want. You need at least one environment where a person can go and check something. Pulling back from that, you need this first environment depicted. You need at least one environment that is a test automation environment. I like to call it the TDD environment to invoke the concept of test-driven development. You need at least one of those so that you can run automated tests against a fully deployed instance of your application with all of its moving parts. If you don't have that, that's a missing piece in your platform engineering strategy. And I'm not going to talk about Redgate's flyway tools, or you might see some of the code in this sample because it's there, but it's kind of out of scope for this presentation. Now, if you're interested in this DevOps architecture poster, what I just showed you is only the top 1/3 of that poster. Just send me an email. I'll be happy to send you a full high resolution version of the entire DevOps poster. That'd be just send me an email or a note somehow. Okay, so let's get into how Octopus Deploy looks in this type of environment where we're building, we're containerizing the application, we're packaging it up, We have a container in Azure Container Registry ready to go. I want to talk first about lifecycle. This talk is not a getting started with Octopus Deploy. All of you probably are users of it and are familiar. You've been watching it all day. And I want to talk about the lifecycle. It is so important that you configure the lifecycle so that when you look at your dashboard of deployments, you have environments and deployments that move from left to right. If you look at your dashboard and you see just a checkerboard of environments where you have the circle slash and some don't apply, and it looks like this weird grid, then you've configured your life cycles incorrectly, and give it some attention. So I'm going to show you the simplest of life cycle, and it's this: your TDD environment, then user acceptance test, and then production. That's in this example where you have 3 distinct types of environments and you have to have at least one of each. That is your life cycle, because this creates that linear structure where we have a new build, we deploy it to the TDD environment first, which is our test automation environment, no humans allowed, test automation. Then we deploy it to a manual test environment. And of course, if you have 2 or 3 manual test environments in sequence, this is where you would have them in sequence. And then it goes to production. And that way, when we go to production, we are promoting a version from an environment, and it's already proven this exact version was vetted in the previous environment. So it's really important that you make sure every project uses an intentional lifecycle. In our consulting and advising all kinds of teams, we see that simple little feature kind of being overlooked too often. And so this is what the tools kind of look like stitched together. And before I pull open the browser window, when a build is running in Azure pipelines, once we've built it, once we've containerized it and pushed it to Docker, and then we're deploying to our test automation environment first automatically, and you're going to see it running in Azure pipelines, and you're going to see it running in Octopus Deploy. That's what it should look like. And in this way, you have your personnel who have configured and built up Octopus Deploy, and they've got full access to Octopus Deploy. However, your build server and tracking work items and all that, Azure DevOps provides that support for all of your stakeholders, even people maybe who are just doing CSS and some HTML, or maybe people who are just looking at user stories or work items, but they want to say, hey, what version is in what environment? They can flip over, they can have full access to Azure pipelines, but you don't have to have that broad set of users have to have access to Octopus Deploy. And so it gives you that flexibility, and that way, Azure Pipelines also has a mirrored image of your lifecycle. So that's what really you want, so that you have full visibility to all project stakeholders in Azure Pipelines if you're using that. And by the way, when you're configuring these tools to work together, there's one configuration item that I want to call out, and on line 141, right here on the screen, you can see deployment progress is true. Now, by the way, this is a file that is the configuration as code that is in the .octopus folder that's stored in the Git repository that represents the configuration of this particular project. And we are using the create release task, and we're setting deploy to environment, which is TDD, and again, line 141, deployment progress is true. If deployment progress is false, then it's a fire and forget. Your build server is just saying, hey, create release, please, and that task immediately returns, and it's asynchronous, and the build server can continue on. Deploy progress is true makes it a blocking call, and all of the logs from Octopus Deploy stream back to the build server, so that the build server can also record all of those logs and wait for it to finish. Because in a test automation environment, we want to wait for it to finish, because then the build server is going to run more tests, and it's going to run those tests against the fully deployed environment. And so we see a lot of teams that don't have proper test automation environments, so that you can really fill out the test-driven development strategy, not just unit tests, which are important, not just component level integration tests, which are important, but full system tests, end-to-end tests with everything deployed in a representative environment. Doesn't have to be production scale, but representative in the right shape, as opposed to just running things on a developer workstation. Okay, I'm also going to highlight. Actually, I'm gonna come back to the slides. I want to show in the web browser as I pull it over. I want to show you how this looks. Okay, so we have a repository. It was .NET 8. We upgraded to .NET 9. So, but again, there's nothing magic about the .NET versions that change how you do this. Okay, Azure pipelines. We have this. We're going to go into the TDD project, and we're creating release. And you see this delete TDD resource group. We automatically create the test automation environment, and then once we run our tests, we automatically delete it because it has served its purpose, and that limits our Azure bill. But there's a lot of logs that I'm not going to go through here. But let me jump over to Octopus Deploy to show our project, or the process of the deployment project. And we can see that inside Octopus Deploy, inside that, if I go back, inside this create release task in Azure Pipelines are all the steps to actually create the environment and then deploy our application. So we're going to create an Azure SQL database. Then we're going to create the database schema. And because we dynamically created it, we need to run a little bit of code to get the connection string that was just created. Then we happen to be using Redgate Flyway to actually run the scripts, create the tables. Then we're creating the container app environment and the container app itself. Then we're getting the dynamic, fully qualified domain name, and then we're going to add the revision. As we go into this is where I'm going to pick back up, because we have a script here. So if I go back to the slides and go to the next one, this is the magic couple lines of code that deploys a new version of our application to Azure Container Apps. Azure has come a long way since the very first version of Azure App Service. It is absolutely trivial to push a new version to an existing Azure Container App through Octopus Deploy. And Octopus has a massive step template library with everything, but it's become even simpler because Azure, you could do everything with Azure from its command line. And so we see that, I went too far. Okay, we can see that line 35 here on the screen, we're going to log in essentially. 35 and 36 is just logging in with our credentials, and they're just PowerShell variables. We're pulling them from the variables in our Octopus project. And then line 45 is where we call AZ Container App Update. And this essentially creates a new revision, which I'm going to show you in the Azure portal, what that looks like. And we basically take the $ container image. That is the name of our container image. And we're saying, hey, this container app, I want this image to be deployed here. Go. And it does it. And I'll talk about how that does it. So that's the magic inside Octopus Deploy to make that happen. So the complexity isn't necessarily in, oh, how does Octopus Deploy work with containers and work with container apps? That's pretty trivial, but you just need to know the Azure Container Apps flavor of Kubernetes. And so I'm going to talk about that a bit. All right, let's jump back into the browser with, let's see, here we go. Pull that back over. Let's go to the Azure portal. And so I have a lot of resource groups here. I'm just going to jump into let's say jump into this prod environment. Now, obviously, this isn't prod. This is like demo prod. In in the real world, I would not have a resource group for a production environment in the same Azure subscription as resource groups for non-production environments. I would use the security boundary that is the Azure subscription. I would have a different Azure subscription for production, and then I would have an Azure subscription for non-production, because invariably you want different security controls on there. Okay, so we're going to a production environment, and there's two things here that I'm going to show you. One is the Container Apps environment, and here it is. And so if I open that in a new tab, and then I'm going to open it here. Okay, so this is our Container Apps environment. This is where we would mount volumes, and this is our cluster. This is my cluster that Azure kind of simplifies. And now if I go to apps, I can have any number of Kubernetes pods, which are called container apps, any number of them right here. I have one, which is just our kind of our running server app. And so I'm going to click inside here, and Octopus Deploy created this for us. And here's the application URL. If I control click in here, then I see that it's an older version of the application. Again, I just upgraded from dotnet 8 to dotnet 9 because we just had dotnet conf. dotnet 9 just came out. Okay, so this is an older version, and I have a version URL /version, and I can see that the version number is 2.4.49. Okay, it's a few versions back from current. If I click back over to our pipeline, see 2.4.83. And so that's what we'll look for, 2.4.83. Now, I want to harp on something. I really want to harp on something. Our build number is 2.4.83. You can make the revision names in Octopus anything that you want. But if we go back to deployments, make your version names the build number from your build server. That way you have traceability, okay? It's possible to be creative and name your releases all kinds of stuff, and maybe you have a reason, but make sure that you have traceability and you put that build number in your revision name. On top of it, you want let me talk about your image names as I go through here. Okay, so I'm going to click over to revisions and well, let me just show you containers. Here's our container app, and you can look at the image tag. And by the way, there is in Azure, there's nothing called version, but in the Docker world, there is an image tag. You can tag a container image. A container image has a name and it has a tag. The best use for those two fields is to make the name whatever the name of the component that you're building. In this case, the application we have is called Church Bulletin, and the website component is literally just called UI. So our image name is churchbulletin.ui. That is the perfect usage of the image name. Okay. Now the image tag, the perfect usage of tagging that is just the version number, just the build number straight from the build server that flows into as the release number or the release name in Octopus Deploy, and also has absolute traceability to the image tag. That makes life so much easier when you're automating all these things because you have direct traceability. Okay, let's go to revisions and replicas. Once you have a container app, then the child concept is revisions. When you want to change what is deployed to this container app, you don't actually change it. You add a revision, and the Kubernetes pod under the covers does its process of stopping the flow of traffic to the old container, spinning up the new container, starting the flow of traffic to the new container, and then doing a subnet DNS switch so that everything is stitched together. And so in order to do that, I'm going to do this in Azure so you understand the flow of what's actually happening when, remember back here, Octopus Deploy, in effect, is integrating by running this command. Okay, regardless of step templates or whatnot, AZ Container App Update is happening against Azure. And so I want you to understand what happens in Azure when AZ Container App Update happens, because in Octopus Deploy, we don't have to run commands for set something up, switch things. With App Service, we actually had to do that. In App Service, we had to deploy to a staging slot. Then we had to wait for it to spin up. Then we had to check that it was healthy. And then we needed to come back and swap the slot. And that configuration needed to go in Octopus. I mean, you could do an auto swap, but with Container App, it's kind of the same concept. Kubernetes does the same concept, but it's completely automatic under the covers. So let's go back to the browser. Let's see here. Pulling up the right screen. I just had it. Okay, there we go. Here's the screen. So what we're going to do is we're going to go into this revision. Actually, no, not going to go that way. I'm simpler. Create new revision. Create new revision is here, and go to main. Now, by the way, I talked about it in init containers and sidecar containers. This is the UI for that. And of course, with Octopus, you're going to use the command line version. But we have the concept within a particular Kubernetes pod. Remember, a container app is a Kubernetes pod. We can have an init container that runs before the app containers, and we can also have a sidecar container that just does something on the side, and we just need to make sure we don't compete for the same ports. So let's click on this, opens it up on the side, and I'm going to change to managed identity. Okay, so we have our registry, which is onion architecture, flyway, blah, 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 container registry. And then the image, well, we have one named image, which, by the way, this is, we're looking at this registry, and we have one stream of images, and this is the name. An image tag in this registry, we have lots of images, and the image tag is just the version number, okay? And if you remember, we were way far back, like 2.4.49. We're going to deploy latest 2.4.83, and we're just going to set system assigned. Okay, when we do it manually, you have to click a few. And of course, when you deploy something, you can either use the same CPU cores, or you can change it out. We're just going to leave the same because this simple app doesn't need much. And if we go in here, I'm just going to show you again. This is the simple Blazor WebAssembly app, and weather and counter. That's it. But what's important here is I have this web API that shows me the version number, and it's there. But let's look at, let's see, create. Let's look at the, oh, I didn't click create. Okay. As it deploys, we're going to just refresh, because I want you to see it doing a few things so that you understand what's actually happening under the covers when Octopus Deploy has received the name of an image from a build server. It's been Dockerized, and we maybe created or used the environment, and now it's time to deploy a particular version, and we're just telling Azure, hey, please do this. So it takes a little bit, and Azure runs at the pace that it runs at. But if I've learned that if I can refresh it, then what we're going to see is the replicas coming up. All right, so there we go. That's what. So 309, we're activating a new version. And when you do it automated through Octopus Deploy, you end up getting this hash. And when you do it interactively through the Azure UI, it auto assigns a 000 number. So when you kind of see that, hey, why the difference? Well, it's because I'm manually doing it with a mouse, whereas when you do it in an automated fashion, you end up getting this hash. So if I just refresh, and I know you're going to be Well, be patient with Azure, but I want you to see this process. It doesn't do a good job of auto refreshing, but you're going to see it's activating this new container. It's spinning it up. It's doing its startup process. Our old container is still running. So if I come over here with the version number and do a refresh, we're still 2449. Okay, we're still there. So pretty soon we should see that the new one is activated, and sometimes it'll take 1 minute. So as you're thinking about this process, when you deploy, know that you're going to have some asynchronous deployment process here where it's running. Okay, now we're running the new one, and at the same time, Azure is deprovisioning the old one. But at this point, when I refresh, I have the new version. So the new version is running, and if I continue to refresh, it's going to deprovision, and which is effectively getting rid of it, shutting it down, and then making that container go away. So that ends up being a little bit quicker than there we go. And now we're fully done. And so if I go over, we are 2.4.83. And if I go back to the web page to see, what did we change? We can see on the home page, hello, dotnet9. Okay, because we deployed the latest version of this particular application. So let me go back to the PowerPoint. Okay. Now, I do want to talk about runbooks real briefly. We talked about operations earlier in the SHIP conference. One of the simplest runbooks ever is to scale up and down your environment so that non-production environments scale down almost to zero overnight because we're not using it. In production, if you have users that they're all at the office during the day and the light usage at night, you still want to scale them up and down. So that's the perfect, if you've never used runbooks before, that's the perfect initial runbook, is just to scale it up and scale it down per environment. And then you add some triggers that is just a schedule, at 8 a.m. in the morning in your area or 6 p.m. to scale it down. And the process that it runs, as I jump into the scale down, the line to look at is the script file in package at the bottom of the screen. We're looking for the scale infrastructure.ps1 package in churchbulletin.script. Okay, so we're looking at that. Now, if I jump over to Visual Studio, it's in my Visual Studio solution, scale infrastructure.ps1, and the magic lines are line 49 and line 50, where we're really just doing an AZ container app update. And if you look at the parameters towards the right side of the line, CPU and memory, and we can parameterize that in our Octopus Deploy variables for what level it means to scale up and what level it means to scale down. So for our application, we want to scale down the container app, and we want to scale down our Azure SQL because Azure SQL has the same concept. So those are, if you have not used Octopus runbooks before, invariably, you could save money on Azure just by having a scheduled scale up, scale down of whatever shape of environment you are. So I wanted to harp on that. Now, we love making teams effective. If you go to clearmeasure.com/assessment or /developers assessment, then it'll help you see how you can improve your team. But I want to just kind of skip through these slides real quick and save some time for questions, because I know that I went through this information very, very quickly and it's very dense. There's a lot there. So I know we have a fantastic audience, John. Do we have any questions that have come through?
I'm just looking here. There's lots of tips and tricks being provided by Joanna, which is awesome. So we provided your LinkedIn there. If you want to reach out to Jeffrey, you can reach him here, or you can reach him in another number of other places.